Hi, my name is Josh Panfil. I'm an actuary here in Chicago, Illinois, USA. And today I will be going over how to use R Markdown. The resources, as usual, will be R for data science, as I assume almost every presentation so far is used. And then another helpful guide comes from the R Markdown cheat sheet and the R Markdown reference guide, and we'll take a look at those in a bit. So let's start with the basics. What is Markdown? Before we even get to R Markdown, we'll talk about what Markdown is. So according to the Markdown guide, Markdown is a lightweight markup language that you can use to add formatting elements to plain text documents. So what that means is when you're working with R Markdown, really you're just using plain text like you're writing in Notepad, for example, and then you can add in what's called the markup language, which is what Markdown is. Markup means you add in other text elements, and then eventually what will happen is you'll compile all of that text with those markup elements, and the output will be changed. So if you think of making a document in Microsoft Word, for example, it's very common that you'll click through menus, you'll add in objects through menus and shortcuts, whereas with Markdown, you'll use other text element within the text you're writing. And I've included a little example here at the bottom of this slide. So as you can see, the right is the actual output once you compile the Markdown document, and the left is how you actually build it. So the left shows that everything is just text rather than going through menus. So you can create hyperlinks, you can create different types of fonts and headings, as we can see here with Dillinger, and you can add bulleted lists, which are just using dashes, and so on like that. So we'll also take a brief look at the Markdown guide website. If you have general questions about Markdown, you can go to this guide, but otherwise there are specific guides just for R Markdown. Now, why use Markdown in general? So the top reason, these reasons come from the Markdown guide, is flexibility. You can do text editing on any platform. Again, comparing to Microsoft Word, you might have issues with flexibility and portability because everything needs to be done in Microsoft Office. But with Markdown, you can work in literally any text editor. You can work on any platform, whether it's Windows, Mac, Linux, and you can still read the text no matter what. Another nice option is that it's future-proof. So for example, if you ever need to look at a very old Markdown document, all you have to do is open it up in a text editor and all the text will be right there as usual. Finally, widespread use. It's very common in data science. It's common on websites like Reddit, for example. So it's just a very powerful yet very simple way to create nice looking documents. Now, why use R Markdown specifically? Again, looking for advice from R for data science, there are 3 reasons given there. The first is easier communication with decision makers. So whenever you're communicating in business, for example, or communicating research in academia, you have to remember that there are different audiences you'll be speaking to. For example, I'm an actuary, so when I work with other actuaries, I'll be a lot more technical. I'll show how calculations are done. But now, if I need to talk to non-actuaries or different types of managers, then in that case, the exact calculations are not as important as the overall conclusions. So that's one of the things that we can do with R Markdown. is when we're talking with decision makers, the people who don't need to see the exact code, R Markdown allows us to easily hide the code in the document while still using the output. And that way we can communicate the conclusions. Similarly, but in the opposite direction, when you're working with others in your role, for example, if you're working with a data scientist, they definitely want to see your code. So R Markdown will allow you to have your conclusions and your code in the same exact notebook, in the same document. And finally, you can use it as what Hadley calls a modern day lab notebook. So what he means there is you can have your code in specific code blocks, and then along with that code, you can have nicely formatted notes. So you can take down your thought process as you actually work through your code. That way, when you come back in the future, everything's right there and it'll be much easier to remember where to go and what you've actually been working on. So for this presentation, I'm going to do most of it actually in RStudio rather than going through slides. So let's go over to RStudio now. Now I've actually done a few other presentations so far, and what I have on the screen now are the R Markdown documents that I use to help build those. We'll get into this more later, but R Markdown gives you a variety of different output options. So I built a very basic PowerPoint for my previous presentations, just to help me get everything in the format that I want. So for example, you see here, these are creating new slides. Really convenient, really easy. Now, along with that, there's also the ability to do more interactive work with R Markdown. So again, when I was working on the functions presentation, I did a lot of work just straight in R Markdown. So a really basic demonstration here is I was sharing my screen, and in these, I'm able to code, and then right beneath that code, we get the output. So that made it really easy to share my coding process as well as look at the output as it goes. So now in RStudio, to create a Markdown file, just go to New, and what it does is it gives a really nice template for us to use. So let's call this SWB Markdown, and we'll put my name again. As I mentioned earlier, there are different types of output that you can choose. We will go with the nice and simple HTML. What that means is the final output of our Markdown document, you'll just open in any internet browser. Very, very convenient. Okay, so now we've created our template for our Markdown document. So first, before we actually get back to work, there is a very convenient cheat sheet for our Markdown that we can access through the help menu, going to help, cheat sheets. That will open up another web page for us, which will download the document. Very dense, but it is extremely helpful. Again, as you're starting out learning Markdown, you'll definitely forget a lot of these things as you go. I always forget them when I have to go back to R Markdown, so it's great to have a cheat sheet for you. And then also along with that, there is the R Markdown reference guide. Now this one is a little bit longer, but again, it's just a breakdown of the different options that you can do with R Markdown. Now let's take a look at what RStudio has created for us in this R Markdown template. So the first component at the top here is the YAML header. So that's spelled like this, YAML. And what this does is it provides information for the output and for just background information that we saved with your document. This portion is indicated by the 3 dashes, and it is optional. So if you delete it, it will not completely break it, but it is helpful to keep. The second type of component are the code chunks. These are indicated by the 3 backticks. And then within these curly brackets after the first 3 backticks, we can provide information for how we want R to run within this code chunk. We'll get into those different options in a minute. And then finally, the main component is generally the raw text. So that's what we have here. So you don't have to indicate anything to determine this as raw text. It is the default. But what you can do is use different symbols to change what the output looks like. So as you can see, those are the basic components. Now to create the actual document, what you can do is what's called knitting the document. So there's a shortcut for it up here, or you can use the keyboard shortcut, Control-Shift-K. First, it will ask us to save the document. Do that now. And now at the bottom, we see that it is rendering the document. You might need to install some extra packages, but generally, this is exactly how it'll work. So now, as you can see, the YAML header converts to a nice document header automatically for us. And what we can see immediately now is that this code chunk doesn't show up in the output. So as I mentioned earlier, you get to choose what code actually shows up and what code doesn't. Now to the raw text portion, you can use these symbols to change how the text looks. So in this case, we use the $! to create a title section. We allow links to be created. So we can click on this, R Markdown Studio, and that will take us right to that link. And along with that, we can also do things like bolding text, italicizing text, and so on. Now, in this case, we want this code chunk to output, so we don't include this include equals false section. Now, this section, we actually see the code and we get its output below it. And the rest of the example is pretty similar. Again, now in this case, another way to suppress the output of the code is to use echo equals false, but that parameter still allows the output itself to show up. So we can hide the code, but keep the plot. So again, it's all about flexibility and knowing your audience. Okay, so now we're going to go through what we've been looking at, and we will start basically wherever R for data science starts. So we've already gone through some of that. Now we can get on to text formatting. So text formatting just means how the output looks once you knit to an R Markdown document. So as you can see with this simple sentence here, I have a few different types of symbols already. We have double asterisks around the word this, single star around is. We have the backticks around Markdown. And now also we have on this next line, we have some the caret character and then the tilde character. So now let's see what happens when we knit the document. So using Control-Shift-K on Windows, we wait and it runs. Now we have what we've already looked at, and now we get our text formatting section. So first off, what we see is the double pound sign creates a larger text for text formatting. Then double asterisk bolds the word this, single asterisk italicizes, and then backtick gives us a sort of code format. That will be really useful later on when you want to differentiate in your writing between regular sentences and thoughts, and we can use the backticks to say this is code and this should be in an actual R file. It's not just regular text. Now the pound sign, the hashtag, the number of them that you have at the start of a line determines the behavior. So 1 pound sign is called the first level header. And then as you see, as we add pound signs, the text gets smaller and smaller. So that way you can kind of think of this like a title heading and then next level and another level beyond that. Next up, we have bolded lists, of course, which are very common and useful. To make a bolded list in R Markdown is very easy. You literally just add a dash at the start. So let's remove that. Now let's run it again. And as we can see, now we have no bullet there. Let's drop this down. We just add the dash, line these up, and now knit again. And as you can see, oops, I forgot to add spaces. So we got some different output there. There we go. So now we have bolded list. But now also what you can see is that we can use different tiers. So by putting extra spaces in front of these dashes, they move up a level. And the symbol even changes. Now, numbered lists work a little differently. So normally what you think you would expect is you would start 1, 2, and so on, and then you would get your numbered list. As you can see here, number 1, number 2. But actually, the way Markdown works is it just looks for numbers starting in the proper format. So even though we have 1 and 1, we get 1 and 2 here. So that's just a convenience option for us that Markdown does for us. Now another really common type of data that you want to include in reports, whether it's for other data scientists or management types, really any level of report, are images. So we can do that in a few different ways. We can use the greater than and less than symbols. That creates a hyperlink. So we can click that and it will take us to this example domain, which is literally a website that exists just for people to use as examples. Is that nice? So that's how we create hyperlinks. Now, if you want, as we saw before, what we saw is in the Markdown document, we just saw the bare link. Now, what if we want to make that that link say something and go somewhere else? So we can change the name of the link. And now, as you can see, we've changed the name. It looks nicer rather than just having a bare link. Now, next up are images, just said are really helpful. So the way to insert an image, first we'll do it the simplest way, which I believe is just exclamation and then the, let's see, okay. So what you do need in this case is the brackets here, then the file path to the image to output it. So in this case, since I have the image document or the image file in the same directory as the R Markdown file, I don't need to add a path. But if it wasn't, then you would have to add a regular path file to it. Now what we can do then in the square brackets is add a caption. So again, if you take a look at really nice articles that you see online, you'll see things exactly like this, where images generally have captions. It increases how nice everything looks and makes things more clear and helpful. So that's always recommended. Now, next up, we have built-in tables. The way you build these are with the vertical bars. And then to create a header row, you have to add in a line of dashes. So what we get here is it gets formatted like this for us automatically. So if we didn't tell it to bold this first line, it just assumes so because we add that line in and it creates it as a header column. Now, as you can see, we actually need that header, this extra line of dashes, for the table to render at all. As usual, there's a huge amount of extra functionality that you can add into tables, but we'll keep it simple for now, and we can get into more complex work later. Now, really, the thing that sets apart R Markdown from other types of output formats is the ability to add code right within your document. So you can have a document that contains both text, images, as we've seen, but then you can literally run code within that document. So first off, just some things to remember. We can add code chunks with Control-Alt-I, like that. We can use the insert button icon in the editor toolbar. I always forget those options, to be honest, and I just straight up type 3 backticks, curly brackets. We tell it it's going to be R, and then we need to close it off. Now the R Markdown file recognizes this chunk as an actual code chunk. Now, before we get into running any code, one thing we can do here first is the first word after R in the curly brackets. That is the chunk name. So that has a few benefits. We can use it for navigation. Down below the editor pane, for example, we have all the different chunks and different sections. So let's see, where did that chunk, there we go, chunk name right there, chunk number 4. So if we want to jump to this spot later on, we can easily do that. Another benefit is that file names will use chunk names when necessary. And finally, chunks are also used for caching, which we will take a look at soon. Now, as I mentioned, chunk name goes here, but we can also add in a bunch of extra chunk options separated by commas. So let's add in some code here, see what happens. Okay, so now we have actual code that we typed here. And then on the next line, within this formatting, we get the output as well. So now what we can do with these options, for example, eval equals true, that means the cell gets evaluated. We can set that to false. But so the chunk still appears, but it doesn't get run. So now we no longer get that output. Include is similar. Now include, let's set that to false and see what happens. Now it's totally gone. And it doesn't show the code or the output, but it does run the code. So keep that in mind. You can use include equals false chunks to use to kind of create variables that maybe you'll want to use later on. Echo can be used to hide the code, but not the results. So as you can see here, now we get that result back. And there are many others. So for example, if you ever run a function and maybe you have something set wrong in the function to the point where it doesn't error out, but it does give you a warning, well, you can use the message and warning flags to turn those off if you want to ignore warnings. As always, be very careful with that. Sometimes warnings aren't super big deals, but sometimes they mean that you've actually made a mistake in your code and you want to fix that. Now we can also use the result equals hide to stop the output. An important one that I've run into for teaching is the error option. So let's say I do this. Let's say I do error equals true. And now I put in code that can't run. So let me highlight and try to run that, the usual way. And of course, R does let me run that because it recognizes it as 2 plus minus 2. Let me pick a better option. Now let's try to add a number and a string. There we go. So I got my error correct this time. So now let's say I'm teaching this. I'm teaching errors. What I can do is say error equals true. Oops, and I am struggling with this example. Come on, I'm used to working, I've been working in Python a lot lately, so spelled true in the wrong case. All right, here we go. So This is great because the code shows, and now the error also prints, but the main thing here is that the entire rest of the document prints. So like I said, if I'm teaching some R basics, it's great to learn through mistakes like I just did. So being able to print out the errors as you go is really helpful. Cache is also a helpful one for when you're building an R Markdown document. And as you're working through it, maybe some code blocks take a long time to run. But what you can do is set cache to true, and it won't rerun that block every time. It will load the results from your disk. We'll actually get more into that later because it's important. So now let's move on to tables again. So let's say we have this data frame. Let's see, what is this? And all we want to do is print this data frame. And let me just close that out so we don't get bothered in the future. Now, the usual output for data frames is pretty ugly. That's why I named this code chunk table ugly. It's very basic. There's no extra formatting applied to it. So what we can do is use the knit R package, specifically the cable function. And what we can do then is use that with our printing, and it comes with a bunch of extra options for us. So for example, this one, I set a caption, look at this pretty table, and come on, let's look at it. You know, we get nice formatting for all of the different columns. The column headers are bolded automatically. Really nice. And we can also take a look at the help for it as usual. And we can see there's a whole bunch of different options for us to make things easier. So for example, we just used the caption. We can also throw on a nice label. And I don't seem to see where that printed to. So once again, now let's look at the oh, that's for referencing. Oh, well, I thought that was for printing. Not a problem. So we will just ignore that for now. R for Data Science also does recommend several other table options for nice printing and formatting. So we got Xtable, Stargazer, Pander, and so on. Now we'll take a look at caching. Now, caching is a very powerful and useful feature, but it's something that can also get you messed up if you don't know how to use it properly. So when we set cache equal to true, what that tells R Markdown is that we want to save the results, and then when we re-knit the Markdown file in the future, it will just load those results that have been saved from disk. So let's say we have this cell here where we load in this very large file that is two observations. So yes, very large. Now let's say we have a code chunk where we want to do some processing for that raw data in the above cell. Now, if we set this processed data chunk cache equals true, whenever we reknit the document, it's just going to use the cached results. Now, the issue there is that if we change something that happens to raw data, this code chunk is not going to pick up on that. So all the transformations that we do will continue to be done on the old data, and we'll keep this processed data that's out of date. So with that, to summarize again, this chunk won't run because we have cache equals true, even if this raw data is different. So then we'll have a mismatch between what should be. So we have a few options for working on that error. One such option is depends on. Depends on should contain a character vector of every chunk that the cached chunk depends on. So in this example, what we do is add depends on raw data, because that is the name of the chunk here that loads this data in. And what it does is it will run this code if it detects any changes in the code up here. So let's say I add a step, raw data, new column, something. Depends on will detect that change. However, there is still another important gotcha that you have to be aware of. If we change the file itself that we're loading here without changing any of the code, then this depends on chunk will not be triggered. So what I mean by that is if I go to my folder and I open up the actual file, now we save that, or if we did, it's right now it's locked by RStudio. But if we changed that file and then reran everything, depends on would not catch that change. So finally, there is another option to catch even that, and that is the cache extra function. Let's go straight to what Hadley describes as cache extra. You can use the cache extra option. This is an arbitrary R expression that will invalidate the cache whenever it changes. A good function to use is file.info. So for example, let's just do file.info on this and see what we get. See, it's just some random output that's not necessarily actually important to us. But what happens is when we add the cache extra, it will look to see if the result of this R expression change. So if we went in and changed a very large file in Excel like we wanted to, this file.info output will change. Then cache extra will know that raw data has changed. And then that will flow through to the transformations that we have in these other chunks. So yes, that can actually get pretty complicated conceptually, especially if you're not paying attention. So one thing you want to do is just run initr clean cache every now and then, and that will clear out your cache. And that way you can rerun everything knowing 100% for sure nothing's cached, nothing is saved. We can all just let it go. Now the next section are global options. So sometimes you want a particular option to run for every single R chunk in your entire notebook. So of course, what we could do is add into every single one eval equals false, echo equals false. But if we don't want to do that and you have a lot of chunks, or you change your mind at the end, then what you can do, put this kind of chunk at the start of your document where you use initr ops chunk set, and then you can set echo equals false for everything. Nice and simple. Now, a really cool thing that we can also do with R Markdown is inline code. So that contrasts to what we've been doing already with code chunks. So for example, let's run these. We have x equals 1 and y equals pi. Well, what if we want to write a sentence that references these actual created variables, and we want their values to print out, not just the character or the variable name? Well, that's what we can do with inline code. What we do with that to create inline code is backtick R, and then we can add in any R function, any R expression that we want, and then close it out. So for example, if we jump over here, I've also added a function. And now let's take a look at what happens when we knit. And we jump down to the inline code section. So as you can see, we've written our sentence, we assign the value, and we get 1 instead of the letter X. And now using the regular backtick without R, we can make the X look like code. And then the same thing happens for pi and y. And now, again, we say what we want to do here. We've omitted the R because I want this function to show as code. And then the final step, now we've got the rounded pi because we actually let this function run by using inline R. So again, to do inline R code, all you have to do is backtick R, and then all code goes here, and you can run whatever you want, and you can reference the variable names that you've created in code chunks. So as usual, very powerful because it lets you choose how you want to output your work, and you can put it right in together with sentences. Okay. So one thing that you've already seen me do here is for troubleshooting, like if your markdown isn't knitting into a full document, well, what you can do is go into each chunk and run it interactively as if this is a regular R file. So for example, up here, right now, X is 1. I can change it to 2 and then hit Control Enter. And we see on the right that X is changed. We can add this. And we also get a nice little output box here. So that's another reason why R Markdown is great for teaching, because you can run your code interactively as you do, and you can even get a nice little output box right within the Markdown editing pane. So for troubleshooting, you're able to treat it pretty closely to just regular R code because you can run it line by line. It's a very convenient option. Now, I had mentioned earlier that the YAML header, which we looked up at the top here, is useful for setting some different features of your Markdown document, like automatic titling and the exact type of output that we want to use. But there's actually some extra features that we can use. First off, YAML stands for yet another markup language. So again, what we're working here is a markup language where certain characters change how the final output will look. So what we can also do with the YAML is set some document-wide parameters that we can use anywhere. And then when we can change it, it can make it easier to change things throughout the entire document. So let's use an example here. Let's take this code that we have. We copy the params, and then we let our first param be my class, and then the value will be SUV. Now we jump back down, and now what we can do is access those parameters like any other R code. So we wait and run, and now look at that. So we've replaced the inline code. It looks for the params in the YAML header, finds the params, finds my class, and then it replaces it with the variable output, which in this case is SUV. So that just adds another layer of flexibility. So let's say I wanted to run a report that looks up a lot of information about SUVs, but then I also need to run the exact same report and run it on sedans. Well, I could just change my class to sedan and have my code based off that. Now we can also have it run our expressions. So let's try this one. Let's see, we add start. Now we use exclamation R to tell it this is going to be an R expression rather than just assigning a string to a variable. Now let's jump back down to our example section, and we'll just add in a line, params, and I think it was start. Let's see if we get this right on the first try. And we did. So again, it's just another easy way to inject some further flexibility. So we used the Lubra date package to create a year, month, date, and it just prints out in line as we expected. Now, one last thing to remember is that this entire time I have been using the shortcut Control-Shift-K to knit to the output style that I have in the YAML header. Well, another option for us is, let's say we're not even working in this file. What we can do is actually just use the R Markdown render function, and we can call it like we would any type of function. So in our case, what we do is we'd go to our file. We would set the input to this markdown file, and then the output format would be one of the available options that is described in this documentation. I won't get into this particular function in detail because there's a lot that can go on here, but just keep in mind that this is another option for you to choose. So let's say you are running a separate R script. Well, instead of using the knit function from the markdown itself, you can just call render from a separate R script and get the same kind of output. Now, another convenient usage of YAML is automatic bibliography. So what we can do, let's make sure I have the bibliography file ready, which appears I do not. Oh, here we go. R Markdown bib. Now we can just look at that with Notepad++ just to see what it looks like. And it just follows this particular format. So now what we're going to do is add this to our header. And what we can do then is reference these citations using the @ symbol, where in this particular format, @ and then the name that we have here. So now let's let that render. Okay, and as you can see, it's replaced this @R base with the name of the citation. And then if we go all the way down, it even adds in a bibliography for us. One thing you'd have to do on your own is add a header for that section, but it does automatically add in the citation, and you can change the different citation formats if you want. So one important aspect of R Markdown, especially for scientists, anyone working in fields where you use mathematics, is LaTeX. LaTeX is another markup language, but in this case, it is extremely powerful and useful for presenting mathematical symbols. So this may or may not be installed on your machine yet. One option for that is using TinyTech install. When I ran this on my MacBook, I had to use a specific setting with TinyTech and a specific function. On my Windows machine, I didn't run into this issue. So I do admit it can be a kind of finicky. But now let's look at the power of LaTeX. So let's say that I want to write out the formula for finding the expected value of a function. Usually typing those symbols, for example, the integrand symbol, that's very, very difficult, or you have to copy and paste. It's ugly. In Microsoft Word, you're inserting and you're using their built-in shapes. Well, with LaTeX, what you do is surround your text with the dollar signs to indicate now you're writing LaTeX. And what you do is use specific, let's see. You use specific LaTeX symbols. So we'll just take a look at this one real quick. And you can indicate a symbol using the slash. So in our case, slash int indicates the integral sign, and then underscore a creates the lower bound, caret b indicates the upper bound. Then we can just put in whatever text we want, and then we can create the dx symbol. So now when we knit everything, what we get is a beautiful mathematical function with all the symbols that we want. This is really, really convenient for any field where you want nice mathematical functions written out. And again, just like Markdown, LaTeX is a very, very flexible language with a lot of other options for tables and images and so on. It's very commonly used with scientific publications because of how powerful and easy it is to use. I just wanted to add that in because it's one of my favorite things to use with Markdown. Now, finally, there are multiple options for output formats. So what we've been using here is HTML document, which means if we go to the folder that we're working in, we get an actual .html file that we can open up in a web browser. So everything that we've created and looked over, we now have that in a browser. That's a really convenient way to pass around because every computer has some sort of internet browser, so you don't have to worry about Word documents or PDFs. But of course, if you want to use those formats, well, you can do that too. So we can, for example, use Word document. Just replace that. Let's see if it plays nicely with us. As usual, you never know. Let's see. Oh, there are some things that I'm going to show later on that can't work outside of HTML output. So that's my fault. Let's see if this works. We're going to see later on some interactive things that don't translate exactly to documents. but still, it does work. And now instead of an HTML file, this time it created a .x that we can use with Microsoft Word or other Word options. Let's bring this back to HTML and get back down to our other options. Now, a really cool thing with Markdown, again, is that there are just a million options that we can always add to our output to make things look even nicer than they already are. So let's do this. I think I have to add a line here. Let's see. Oops. I think I have to add a line for each of these. Let's see if that makes it happy. There we go. So what we've done here is add a table of contents. That's what TOC stands for. So we turn it on. Now we let it float. So as if this file was long enough, it would move down as we move down the page. Let's see if we can play around with the zoom perhaps. There we go. Yeah, so as we move down, it's floating with us and staying up at the top and losing it. So now what else we've done with this setting is just let it fold. So we can hide the third header. So, I mean, it's just a cool way to, again, just improve the value of your output. Adding a table of contents for literally just as simple as adding in some extra options. It's just so simple, so powerful. This is the kind of stuff that you can do that will just really blow away your bosses. They won't expect. They probably haven't seen this kind of thing a lot. So just, throw in the bells and whistles, and you get a lot of good points for that. Finally, another thing we can do is add in multiple outputs. So let's say we also want a PDF. We'll probably get that error again because I took out the always. Let's see. Okay. So in this case, we've created the, let's see, did the PDF create properly? I don't think it did. Let's see what happens if we take this out. Oh, here we go. Yep, as usual, the interactive the interactive section that we'll be seeing at the end causes trouble for non-HTML. So keeping those options in. Let's see. Oh well, it did not render the PDF. Again, that's probably due to the interactive options that we'll be seeing in a minute here. So anyway, the point there was that you can set multiple outputs, but sometimes it may break if you have interactive HTML chunks. Now we are running into, again, just looking at different outputs. So as I mentioned, we have PDF, there's Microsoft Word, there's the open document format that's similar to Microsoft Word, but just an open standard, rich text format, Markdown itself. There is a version that is made for GitHub. If you guys are familiar with GitHub, if you're not familiar with GitHub and you plan to do a lot of coding, absolutely get familiar with GitHub. Finally, there's also the HTML notebook, which is, I should say, similar to HTML document, but the entire source code is embedded, and it's just another option for sharing. It's good if the people that you want to share with need to see every single piece of code. The notebook will be saved as a .nb.html, and they'll be able to see every single piece of code, even the ones that you've hidden. So keep that in mind. Now, finally, you might also want to make presentations. So think of like PowerPoint, for example. So there's several options for different presentation standards: IO slides, Slidey, Beamer, Reveal.js, and R Markdown Shower. Now you can also make dashboards. In this case, this is just an image, but what dashboards allow you to do is stack different output really easily. So for example, in this one, they've made a stack of charts on the left and then a filterable table on the right. Just really nice looking output. That's good for sharing with large groups, for an entire teams to get an idea. Now, as I mentioned, we also have interactivity, which has been causing an issue for our non-HTML outputs. So in this example, I'm using Leaflet. Luckily, this just has some built-in functions for us. It's actually really cool. So rather than a static picture, this gives us an interactive map. The example is in Auckland, in New Zealand. Really cool. We can move around. So this is a great option if you're doing interactive presentations and you need to be able to change things on the fly. Oh man, there's so many different options. Now, just a few more that we will mention but not get into are shown here. DY graphs, data table. This is not the R data dot table. This is a library for interactive tables. I use this a lot in my Markdown because they make just much nicer tables than Cable. There's 3JS for 3D plots, Diagrammer, and Shiny. Now, Shiny, there is a section in R for data science, but I think it's just too much of a time sink. So in that case, I would recommend, if you want to learn Shiny, go ahead and check out the Shiny section and work on that on your own time. It's just too much time for this presentation. And lastly, there are still ever more formats. They never end. There are R Markdown libraries that will help you build websites, Bookdown. So Hadley uses R Bookdown to build his books, and PrettyDoc and articles for other types of articles. So that is the end of this presentation. I'll include this R Markdown file so that you guys can play around with it even further. We've only scratched the surface here. I hope that this presentation has been helpful, and I hope that you see the utility of using R Markdown in your own professional lives. So I'd just like to thank you all again for listening, and good luck with the rest of your R learning journey. Thank you.